Welcome to another video. In this video, we are going to discuss multiple choice questions from thermodynamics. It covers thermodynamic process, laws of thermodynamics, heat engine, efficiency of engine, refrigerator, entropy, and many more. Let's get started. If a fixed mass of gas is compressed in a thermally insulated container, then its temperature आपसे कह रहे हैं गैस इज कंप्रेस्ड इन अदर वर्ड्स उसका वॉल्यूम डिक्रीज किया गया राइट आपसे कह रहे हैं व्हाट वुड बी द इफेक्ट ऑन टेम्परेचर क्या कोई एक्सप्रेशन है which relates volume with temperature? Yes, we have studied Charles' law, which states that volume of a gas is directly proportional to temperature given that pressure and mass remains constant, right? So this makes us conclude कि अगर volume decrease हो रहा है तो फिर यकीनन temperature भी decrease होना चाहिए. This is the statement for Charles' law. उसके अलावा Boyle's law में we see that pressure and volume are inversely related given that the temperature and the mass remains constant. At constant temperature, if the volume of given mass of an ideal gas is doubled, then the density volume double कर रहे हैं. Let's just see volume और density कैसे related है. We describe density as mass per unit volume, and it is obvious from this equation that density and volume are inversely related, right? So अगर volume double हो रहा है तो यकीनन density half हो जानी चाहिए. This makes us conclude that option C is the correct option. Internal energy of a system is generally the sum of kinetic and potential energy of the system. लेकिन जब ये खास तौर पे आपसे आइडियल गैस के बारे में यही सवाल करें तो आप कहेंगे आइडियल गैस की इंटरनल एनर्जी इज द मेजर ऑफ द किनेटिक एनर्जी ऑफ द गैस मॉलिक्यूल्स बिकॉज आइडियल गैसेस के केस में पोटेंशियल एनर्जी विल बिकम जीरो. According to kinetic molecular theory, collision between gas molecules are elastic, inelastic, negligible, or they remains constant. Just recall the postulates of kinetic molecular theory. उसके कुछ 4-5 postulates थे, right? Which includes finite volume of gas molecules, includes large number of molecules, that is total of n numbers, and separation between molecules is very large as compared to the size of molecule. Molecules are in constant random motion. They might change their direction with the collision, and no force exerts between the molecule unless they collide with each other, and even when they collide the collisions are elastic. This makes us conclude that option A is the correct option. Volume of fixed mass of gas is inversely proportional to the pressure, keeping the temperature constant. This is the statement for Boyle's law. Volume and pressure are inversely related. At constant temperature, volume of fixed mass of a gas is inversely proportional to, volume is inversely proportional to what? We just saw here that volume is inversely proportional to pressure. Like एक ही statement है, बस उसको rephrase करके multiple times past paper में आपसे ये पूछा है. Which of the following relation describes Boyle's law? Again, volume is directly proportional to pressure. No, pressure is inversely proportional to volume. Option A is the correct option. कि अगर इनमें से कोई भी एक increase हो रहा है तो दूसरा decrease होगा. All of the following are applications of first law of thermodynamics, except in this chapter we will discuss two laws. We have first law of thermodynamics, which explains the conversion of heat, energy, and work. Then we have second law of thermodynamics, which describes the possible direction of heat transfer. When it comes to second law of thermodynamics, reversible process, that is heat engine is the application of second law. And when it comes to first law of thermodynamics, these thermodynamic processes, isobaric, isochoric, and adiabatic are the applications, right? So all in all, option D is the correct option. Reversible processes are not the applications of first law of thermodynamics because first law has nothing to deal with the direction of the heat transfer. When an ideal gas is cooled at constant volume till the pressure becomes half of the original pressure, then the average translational kinetic energy of gas. In order to answer this MCQ, let's just recall the equation for pressure. Pressure is 1 over 3 density of gas molecules and square of the average velocity of gas molecules. We can rewrite this density as mass of one molecule times total number of molecules available in the container divided by the volume occupied by n molecules, and this square average velocity as it is. Since we are to relate pressure with the kinetic energy, let's just rearrange this equation in terms of kinetic energy. We know that kinetic energy is half mv square. We already have v square here. Just shift this m here and divide this equation with 2. In order to balance, just multiply this equation with 2 as well. And this n over v as it is, right? This is the equation which relates pressure to the average kinetic energy of gas molecules. This 2, 3, total number of molecules and the volume of container are constant. So this makes us conclude that pressure is equals to constant times average kinetic energy, right? And so we can say that pressure is directly related to average kinetic energy. Now we can answer this question. आपसे कह रहे हैं प्रेशर हाफ कर दिया गया है, बताएं what would be the effect on average kinetic energy. So looking at this equation we can say कि average kinetic energy भी half हो जानी चाहिए because they are directly related to each other. Here we have two laws of thermodynamics in this chapter. First law of thermodynamics says in any thermodynamic process, when heat energy delta Q is added to a system, this energy appears as an increase in the internal energy of system, which is delta U, plus the work done by the system on the surrounding. So this is the equation for first law of thermodynamics. Let's just use this equation to answer this question. If a system absorbs 2090 joules of heat absorbed by the system is 2090 joules. Following the convention, whenever the heat is absorbed by the system and work is done by the system, we'll take them positive. And whenever the heat is extracted from the system or work is done on the system, we'll take them negative, right? So since this is the heat absorbed by the system, we'll take it to be positive, and then the system does 400 joules of work. So work done by the system plus 400 joules. Change in internal energy of the system, that is delta U, will be, just put these values in this equation. Delta Q equals delta U plus W. Rearrange this equation so that the change in internal energy becomes the subject of your equation. This becomes delta Q minus W. Change in energy is 2090. Work done by the system was 400 joules. That means the remaining is utilized and stored as the internal energy of the system. That is, the correct answer to this question is 1090. That is option C is the correct option. Then second law of thermodynamics. We can state second law of thermodynamics in multiple statements. These are the two main statements by Kelvin and Clausius. It is impossible to construct a heat engine operating continuously in a cycle which takes heat from a heat source at higher temperature and performs an equivalent amount of work without rejecting any heat to a heat sink at low temperature. Then the second statement says it is impossible to cause heat to flow from a cold body to a hot body without the expenditure of work. First law explains that heat and work are interconvertible, whereas the second law provides the description about the direction of heat transfer कि वो कौन सी condition है जिसमें heat could be converted into useful work. Let's just answer this question now. Second law of thermodynamics deals with the conversion of heat into work and the direction of what? The direction of flow of heat, because it says that heat cannot flow from cold body to hot body. It is bound to flow from hot body to cold body. और अगर आप forcefully heat को cold object से hot object तक flow करवाएंगे भी तो फिर you will have to do some extra work, right? So option A is the correct option. Given figure shows a cylinder containing fluid with a movable piston. When piston moves out a small distance delta x at constant pressure, then the work done by the gas is, या तो मुझे directly पता हो कि work done is P delta V. यहाँ पर नहीं है मेरे पास directly delta V, but we know that this is area and this is displacement. Area multiplied by displacement is nothing but volume. So this could be rewritten as P delta V, and we'd say that option D is the correct option. और अगर मुझे ये बात directly ना भी पता हो तब भी I can get to this final answer. मुझे पता है work done is the product of force and displacement. We can write force as the product of pressure and area because we know that pressure is force per unit area, right? Just rearranging this equation to get to this value of force. When it comes to displacement, आपसे क्वेश्चन में उन्होंने बताया कि आपका piston displace हुआ है through this length delta x. Let's just write it here. See, P into A delta x. This is the work done by the system on the surrounding. So this has to be the correct option. This work done could never be negative because this is the work done by the system. And we just discussed the convention कि अगर work is done on the system by the surrounding तो फिर we'll take this work as negative. Move on to next question. Given graph shows different thermodynamic processes in which of the following surrounding does some work on the system. किस केस में surrounding system पे कुछ ना कुछ work कर रही है. See, these are the PV graphs. We have pressure on y-axis and then we have volume on x-axis. Work in terms of pressure and volume कैसे हम represent कर सकते हैं? We just saw here. Work is P delta V. अगर मैं कह रही हूँ कि मेरा सिस्टम कुछ ना कुछ वर्क कर रहा है, इसका मतलब है इस प्रोडक्ट का आंसर कुछ नॉन जीरो है. ठीक, लेट्स जस्ट सी. इन दिस केस 1 आपका सिस्टम इनिशियली था पॉइंट 1 पे, सिस्टम एक्सपेंडेड एंड नाउ इट इज फाइनली एट पॉइंट 2. 1 से 2 तक आने में वॉल्यूम ऑफ योर सिस्टम हैज इंक्रीज्ड, प्रेशर ऑफ योर सिस्टम हैज डिक्रीज्ड. ऑल इन ऑल आपके सिस्टम का वॉल्यूम चेंज होकर इंक्रीज हो गया. सो मैं कहूंगी दिस क्वांटिटी इज नॉन जीरो, दैट टू पॉजिटिव. इसका मतलब है वर्क भी नॉन जीरो है और पॉजिटिव है. पॉजिटिव वर्क कौन सा होता है? वर्क डन बाय द सिस्टम. इट सेज वर्क डन ऑन द सिस्टम. Case A should not be the answer to this question. Now, let's just see case B. In this case B, your system was initially at point 1 and it is finally at point 2. 1 से 2 तक आने के लिए आपके सिस्टम का प्रेशर कांस्टेंट रहा है बट इसका वॉल्यूम चेंज हो गया एंड वॉल्यूम चेंज होकर डिक्रीज हो गया. इसका मतलब है in this case this delta V is negative. This negative delta V leads to negative work and we just mentioned that work done by the surrounding on the system will always be negative. So this is the case जिसमें negative work done आ रहा है. And then let's just see this as well. Starting point was 1, ending point is 2. 1 से 2 तक आने में आपका system compress हो रहा है. See, volume has reduced. So we'd say that यहाँ पर भी delta V is negative, work done is negative, and we'd say that option D is the correct option because case 2 and 3 दोनों में ही negative work done है. That is, work is being done on the system by the surrounding. So option D is the correct option. Then in the given figure, 4 different processes, 1, 2, 3, and then 4. For a constant amount of an ideal gas, all starting at state A are shown in which of the given processes system does zero work on its surrounding. Again, this is PV curve. We have pressure on y-axis and we have volume on x-axis. How do we explain work in terms of pressure and volume? Work done is the product of pressure and change in volume. They are saying कौन सा case है जिसमें work done is zero? Work done will be zero if the change in volume is zero, right? इन तीनों में से, चारों में से कौन सा केस है जिसमें आपके सिस्टम का इनिशियल और फाइनल वॉल्यूम इज सेम? लेट्स जस्ट सी दिस वन. This is the initial volume of system. This is the final volume of system. Volume has changed. It has increased. In this case, this is the initial volume, and then this is the final volume. Again, volume has changed. In this case, one final volume, initial volume, there is a difference. But when it comes to the case 2, this is the initial volume of your system, which is VA, and the same is the final volume of your system, again VA. So we'd say that option D is the correct option. Which of the following electrical devices functions as reverse of heat engine? इसको आंसर करने से पहले हमें पता होना चाहिए हीट इंजन होता क्या है, राइट? हीट इंजन इज अ डिवाइस दैट कुड कन्वर्ट थर्मल एनर्जी इनटू मैकेनिकल एनर्जी. यहीं पे इसको भी आंसर कर देते हैं. डिवाइस व्हिच कन्वर्ट्स थर्मल एनर्जी इनटू मैकेनिकल एनर्जी इज heat engine. This is the schematic diagram for heat engine. We have a hot reservoir, that is a body at high temperature, T1. It supplies some heat to the working substance. This amount of heat is represented with Q1, and then this working substance converts fraction of this input heat into useful work and then rejects the remaining into the cold reservoir, which is at temperature T2, right? This is the heat engine, and the reverse of heat engine is refrigerator. What it does in the refrigerator, heat is flowing from the body at low temperature to the body at high temperature. But then again, because this is against the natural phenomena, so we'll have to do additional amount of work to force the heat to go from low temperature to the high temperature. So the device which is the reverse of heat engine is the refrigerator. Both includes two bodies at two different temperatures. Both involve the presence of working substance, but the direction of flow of heat and the work makes the difference between these two. Heat engine के case में work is done by the system, and a refrigerator के case में work needs to be done on the working substance. Graph shows some variation in fixed mass of an ideal gas denoted by AB. This variation represents an adiabatic expansion, isothermal या compression है. A से B तक आने के लिए we have A, यहाँ पर कुछ volume and then volume at B, which is VB, right? Let's just establish if it is compression or expansion. A से B तक जाने में volume of the system was reduced. So one thing for sure, it was compression. So expansion वाले दोनों options को exclude कर देते हैं. Now this compression is isothermal or adiabatic. उसको आंसर करने के लिए हमें ये PV diagram देखनी है Carnot cycle. Isothermal, as its name suggests, is the process जिसमें आपके system का temperature remains conserved. Slowly, small steps में state of your system is changing from A to B. When it comes to adiabatic processes are quick processes. In this process, there is not enough time for the system to exchange the heat with the surrounding. राइट. सो जो रैपिड रिएक्शंस होते हैं वो एडियाबैटिक होते हैं, और जो स्लो प्रोसेसेस होते हैं, वेरिएशन ऑफ प्रेशर एंड वॉल्यूम, दे आर टर्म्ड एज आइसोथर्मल. लेट्स गेट बैक टू द आंसर. This has to be an adiabatic process because there is a quick change in the pressure while going from point A to point B. So this is compression, that too adiabatic. So option C needs to be the correct option. All of the following are the examples of adiabatic process, except I just mentioned that isothermal are the processes जिसमें temperature constant रहता है. Adiabatic में आपके system का temperature change हो जाता है because आपका system अपनी internal energy को utilize करके work करता है, right? See, इनमें से कौन सा process है जिसमें temperature change नहीं हो रहा, तो हम कहेंगे फिर यकीनन वो process adiabatic नहीं है. This very first option here, melting of ice into water. We have studied in 9th metric as well कि जो भी हमारे पास स्टेट ट्रांसफर के प्रोसेसेस होते हैं, बी इट मेल्टिंग, बॉइलिंग, sublimation, evaporation, condensation, इन सारे processes में आपके सिस्टम की स्टेट चेंज होती है विदाउट चेंजिंग द टेम्परेचर ऑफ द सिस्टम. सो अगर ये मेल्टिंग की भी बात करें, मेल्टिंग ऑफ आइस इनटू वाटर, राइट, दिस इज द प्रोसेस जिसमें सिस्टम की सिर्फ स्टेट चेंज होती है, टेम्परेचर ऑफ द सिस्टम रिमेन्स कांस्टेंट. सो भले ही इन्होंने डायरेक्टली नहीं बताया, लेकिन इट इज ऑब्वियस दैट दिस इज द केस जिसमें आपका सिस्टम आइसोथर्मल प्रोसेस से गुजर रहा है. So जब process is isothermal, तो it goes without saying कि this is the only option which is not adiabatic, right? So option A is the correct option because cloud formation होती, rapid escape of air from a burst tire होता, या quick expansion of compression या compression of air होती. All of these processes are quick and they involve some change in temperature. So we say option A is the correct option. Which of the following diagram shows adiabatic compression? Again, this is expansion because A से B तक जाने पे आपके सिस्टम का वॉल्यूम बढ़ रहा है. These two are compressions because the starting से फाइनल पॉइंट तक आते हुए आपके सिस्टम का वॉल्यूम कम हो रहा है. अब इन दोनों में से कौन एडियाबैटिक है? This is clearly not adiabatic because आपके सिस्टम का वॉल्यूम तो कम हुआ but pressure remained constant. Whereas in this case, there is variation in the pressure and volume of the system, that too rapid variation in pressure, right? So we'd say that option 3 only, that is C, is the correct option. Thermodynamic process in which an ice cube starts melting and converts into water droplets while keeping the temperature of surrounding constant is called which type of reaction? Is it isobaric? Isobaric are the processes in which pressure remains constant. Isochoric are the processes in which volume remains constant. Isothermal processes are those in which temperature of the system remains conserved, and in this particular case, temperature remains conserved. Whereas in case of adiabatic, temperature भी change हो जाता है. In Carnot cycle, this diagram, by the way, is termed as Carnot cycle. At the end of the cyclic path, final temperature of working substance will be higher than the initial temperature, lower than the initial temperature, or equal to the initial temperature. This is Carnot cycle. Your system started at point A, isothermal expansion के बाद it went to B. Adiabatic expansion के बाद reached at point C, then to D with isothermal compression, and then finally adiabatic compression के process से back to the point A. Since the system has regained its initial position, its initial state, we'd say that इस पॉइंट पे अब सिस्टम का जो कंप्लीट वेरिएबल है, दैट इज उसका प्रेशर, उसका वॉल्यूम, उसका टेम्परेचर, उसकी इंटरनल एनर्जी, all of them are exactly the same जो स्टार्ट पर थी, right? So this makes us conclude that the temperature of system will be equal to the initial temperature. इस complete cycle में यहाँ पे सिस्टम का कुछ ना कुछ टेम्परेचर था T1 क्योंकि आइसोथर्मल प्रोसेस था, टेम्परेचर फिक्स रहा. फिर एडियाबैटिक प्रोसेस की वजह से टेम्परेचर चेंज हो गया एंड देन सी तक आते हुए टेम्परेचर T1 से T2 तक पहुंच गया. But then this was isothermal compression, so temperature was maintained at T2. फिर adiabatic compression की वजह से टेम्परेचर वापस इंक्रीज हुआ and it reached the initial value which was T1, right? So this is a cyclic process. और साइक्लिक प्रोसेस में जब भी ऑब्जेक्ट अपनी इनिशियल स्टेट को वापस रीगेन कर रहा है, थर्मोडायनामिक वेरिएबल्स भी अपनी इनिशियल वैल्यू को रीगेन कर लेते हैं. Efficiency of Carnot engine will be 100% when cold reservoir is at 0 Kelvin, energy dissipation is irreversible, both reservoirs have the same temperature, hot reservoir has higher temperature than cold. Efficiency is output over input. राइट. इन केस ऑफ हीट इंजन आउटपुट के तौर पे हमारा सिस्टम वर्क करता था ऑन दी सराउंडिंग एंड इनपुट के तौर पे हम उसे कुछ एनर्जी Q1 हीट एनर्जी प्रोवाइड करते थे, राइट. एंड वी डिसाइडेड कि जो कंप्लीट Q1 अमाउंट ऑफ इनपुट एनर्जी से मिलता है इसमें से कुछ से वो वर्क करता है, बाकी Q2 वो कोल्ड रिजर्वर में डंप कर देता है. इसका मतलब है जो यूजफुल वर्क वो कर रहा है उसके लिए this amount of energy is being utilized, right? So let's just LCM break and rewrite this equation. This becomes 1 minus Q2 over Q1। और हम पढ़ते थे कि हम हीट एनर्जी को टेम्परेचर से रिलेट कर देते हैं, एंड वी कैन रीराइट दिस इक्वेशन एज 1 minus T2 over T1, where this T2 is the temperature of cold reservoir and this T1 is the temperature of hot reservoir, right? Source का temperature, and this is the sink का temperature. Efficiency का बारे में कह रहे हैं percent efficiency. So let's just multiply it with 100. This is the formula for percent efficiency of the engine. आपसे कह रहे हैं कार्नो इंजन की परसेंट एफिशिएंसी जो है वो 100 होगी, 100% एफिशिएंसी. When will you get 100 इस complete expression से? जब ये expression आपको 1 दे दे, right? 1 multiplied by 100 will give you 100. Now, how can you make this value equals 1? अगर मैं इस पूरे expression को 1 बनाना चाहती हूँ तो it is only possible अगर ये ratio मुझे 0 दे दे, right? And this ratio can only give you 0 when the numerator is 0. That is when the temperature of cold reservoir is 0 Kelvin. See, when cold reservoir is at 0 Kelvin. All Carnot engines have zero efficiency if they are operating between two bodies having, again, let's just use this same expression. Efficiency is 1 minus T2 over T1. राइट, यहाँ परसेंट एफिशिएंसी के टर्म्स में बात कर रहे थे तो वी मल्टीप्लाइड विद 100. यहाँ जनरली एफिशिएंसी की बात करें तो लेट्स जस्ट एक्सक्लूड दिस 100. दिस डज नॉट मेक्स एनी डिफरेंस, राइट? आपसे कह रहे हैं कार्नो इंजन जीरो एफिशिएंसी कब देगा? अगर मैं चाहती हूँ कि इस पूरे एक्सप्रेशन का आंसर जीरो आ जाए, 1 माइनस समथिंग शुड गिव मी जीरो. कब पॉसिबल है? जब ये पूरी वैल्यू equals 1, right? And this ratio will become 1 if and only if these two temperatures become equal, right? यानी जो hot reservoir का temperature है वही cold reservoir का temperature हो जाए. So this would give us 1, 1 minus 1 will give us 0, and we'd say that efficiency is 0. Now let's just read this question. All Carnot engines have zero efficiency if they are operating between two bodies having same temperature and same nature of working substance, different temperature and same nature of working substance, same temperature irrespective of the nature of working substance, different temperatures irrespective of the nature of working substance. अभी तक we have established कि temperature same होना चाहिए. इसका मतलब है B और D तो exclude कर दिए जाएं, right? When it comes to the working substance, अभी हम कार्नो हीट इंजन की एक स्टेटमेंट पढ़ते हैं which says वर्किंग सब्सटेंस से फर्क नहीं पड़ता आपके इंजन की एफिशिएंसी क्या होगी, राइट? as long as the Carnot engine is operating between two same temperatures, right? So we say that same temperature and irrespective of the nature of working substance. अगर hot और cold reservoir दोनों का temperature same हो गया, so engine will give you zero efficiency no matter how high the temperature of the reservoir is, right? So in order for the engine to be non-zero efficient, there has to be difference between the cold and hot reservoir. If the source temperature of a system is 500 Kelvin and sink temperature is 400 Kelvin, then the efficiency of engine will be percent के terms में है. Let's just write percent efficiency 1 minus T2 over T1 and 100. I just mentioned that this T2 is the temperature of cold reservoir जिसको हम sink भी कहते हैं, and this T1 is the temperature of hot reservoir जिसे हम source of heat भी कहते हैं, right? So यहाँ पर आपको cold और hot reservoir के terms में इन्होंने value नहीं provide की but source और sink mention कर दिया, no problem. Source temperature is 500 Kelvin, that is T1 is 500 Kelvin, and sink temperature is 400, that is T1 is 400. Put in these values and you will get to know the efficiency. This gives you 1 minus 0.8, which is 0.2, and then multiplied with this 100. This becomes 20%. Your engine is 20% efficient. Efficiency of Carnot cycle depends upon mass of active substance, volume of active substance, pressure of hot reservoir, or the temperature of hot and cold reservoir. It is clear from this equation again that it only depends on the temperature of hot and cold reservoir. It has nothing to do with the mass volume of the active substance or with the pressure of hot reservoir. So option D is the correct option. Maximum possible efficiency of heat engine operating between the temperature limits of 373 and 673 as input and output respectively is, टेम्परेचर प्रोवाइड किया है, टेम्परेचर के टर्म्स में इक्वेशन लिख दें, परसेंट के टर्म्स में फाइनल आंसर है, लेट्स जस्ट मल्टीप्लाई विद 100 एज वेल, राइट। अब यहाँ पर इन्होंने मेंशन नहीं किया हीट सोर्स और सिंक के टर्म्स में, बट इन्होंने इनपुट और आउटपुट के टर्म्स में मेंशन कर दिया। हमें पता है सोर्स इनपुट हीट प्रोवाइड करती है, राइट, और जो वर्किंग सब्सटेंस है वो आउटपुट दे देता है सिंक में। तो इसका मतलब है जो सोर्स का टेम्परेचर है वो ग्रेटर होता है, राइट, और जो सिंक का टेम्परेचर है वो ऑफ कोर्स कम होता है। So this greater temperature has to be the temperature of source. Let's write 673 here, and this smaller temperature has to be that of the sink. So we'll write 373 here and then multiply with 100. 373 over 673 gives you 0.554. Do not forget to subtract it and then you are to multiply it with 100. जल्दी से इसको देख के इस 55.4 को आंसर में कंसिडर कर लें. Subtract it, you'll get 0.446 multiplied with this 100. This becomes 44.6%. So the percent efficiency of the engine is this one. Entropy is best described as, in the thermodynamic systems, there is the important concept of entropy. Entropy is the measure of molecular disorder of your system, right? Or it is the measure of degradation of energy in the environment. So you define entropy as the degradation of energy in the environment. जब भी आपके systems का temperature increase होता है, उनके molecules की freedom increase हो जाती है, right? And consequently entropy increase हो जाती है, and vice versa. जब भी आपका सिस्टम कूल डाउन होता है वो अपने मोर सेटल्ड और मोर ऑर्गेनाइज्ड स्टेट की तरफ जाता है, एंट्रोपी डिक्रीज हो जाती है। जब भी आपका सिस्टम कूल डाउन होता है एंट्रोपी ऑफ द सिस्टम विल बी नेगेटिव, और जब भी आपका सिस्टम हीट अप होता है एंट्रोपी ऑफ द सिस्टम विल बी पॉजिटिव। When any two objects are rubbed together in thermodynamics, their internal energy is, rubbing the objects together increases the temperature of object, right? And we've discussed that in thermodynamics, temperature is the measure of average kinetic energy. So when we say that किसी सिस्टम का टेम्परेचर इंक्रीज हुआ है, इसका मतलब है उस सिस्टम की एवरेज किनेटिक एनर्जी इंक्रीज हो गई। एंड वी हैव ऑलरेडी रिलेटेड किनेटिक एनर्जी विद द इंटरनल एनर्जी, बिकॉज हमने कहा था इंटरनल एनर्जी इज द सम ऑफ किनेटिक एनर्जी एंड पोटेंशियल एनर्जी। तो जब मैं कहती हूँ टेम्परेचर इंक्रीज होने की वजह से सिस्टम की किनेटिक एनर्जी इंक्रीज हो गई, इसका मतलब है कि सिस्टम की इंटरनल एनर्जी भी इंक्रीज हो गई है। So option A has to be the correct option. Let's just see this one last question. It says given graph shows the speed of molecules of gas at three different temperatures. We have this plot for T1, T2 and then T3. On x-axis we have velocities of gas molecules starting from 0 and then keeps on increasing. On y-axis we have number of gas molecules. They are saying which of the following statement is true for the above graph. Temperature के terms में label करें कौन सा temperature ज़्यादा है। See, अभी हमने पढ़ा जब temperature increase होता है molecules की average kinetic energy increase हो जाती है, and हमें पता है kinetic energy is represented as half mv square. So when we say system की average kinetic energy increase हो जाती है, this means system में मौजूद जो gas molecules हैं उनकी velocity increase हो रही है, because this half is constant and mass of gas molecule is also constant, right? So let's just see. मुझे यहाँ से पता चला जब मेरे पास गैस मॉलिक्यूल्स की एवरेज वेलोसिटी ज्यादा होगी, मैं कहूंगी कि वो टेम्परेचर कॉरेस्पॉन्डिंग टेम्परेचर मेरे पास ग्रेटर है। यहाँ पर देखें एवरेज velocity for this T1 plot is this one. Average velocity for this T2 plot is this two. And the average velocity for this T3 plot is this one. राइट इन तीनों में से कौन सा प्लॉट है जिसमें एवरेज किनेटिक एनर्जी ऑफ मॉलिक्यूल्स इज ग्रेटर? See, this is the plot with greatest average kinetic energy, that is with the greatest average velocity. ठीक? So we say that T3 is greater than T2, which in turn is greater than T1. Option A has to be the correct option here. This was all from the multiple choice questions. In next video, we are going to discuss extended response questions from thermodynamics, which includes numerical, theory, and the derivations as well. Allah Hafiz.